Hello, everyone. My name is Luis Vicente Cruz, and this video will be on CS 4540 for the 2025 spring semester. I will be covering my team's project, focusing on building an LLM prompt. So, my team is Group 12, the Neural Net Navigators, and it consists of me, the team leader, Yamilena Hernandez, Ratuluddin, Ira Vizcarra, and Jason Alfaro Trujillo. We will each be covering different aspects of the project, including introducing the project, explaining the rules and constraints, what our approaches for development and testing will look like throughout the process, and a plan for what we expect to have by the end of the semester. So let's get started. Let's start by exploring more about the topic we chose, which is writing a prompt for the game of tic-tac-toe. So, our project aims to develop prompts that an existing LLM can use to play a game of tic-tac-toe. And we plan on tackling this project through understanding LLM prompt generation and being able to specify the rules and constraints for the AI to follow to provide a challenging yet enjoyable experience for the users who engage with this AI. One thing of note is that the hope for this process is to be reminiscent of something like Demis Hassabis's work with AlphaFold, which in essence is an AI network trained on well-established procedures, independent of each other, used together to accomplish something new. And so, in a similar vein, the purpose of this project is to not only understand the topics covered throughout the course, but also be able to put them into practice. And what this means is being able to use topics such as understanding how a large language model operates, analyzing data to receive probabilities and expected values, and using such data for predictive modeling with a constantly updating database to create an AI model for a specific task. And in short, this project would require an overall understanding of LLMs, such as being able to assign an AI a task, training it with the adequate data, and understanding the process enough to be able to troubleshoot it at any time. Um, and yeah, that should be it from me. So I will let my teammate Yamilena take it from here to talk about the rules and constraints for the project. Thank you.
Hello everyone, my name is Yamilena and I'll be covering the rules and constraints for our tic-tac-toe project. Since it's important to clearly define the structure and limitations of the game to ensure a smooth and fair gameplay. So let's break it down into a few key areas. First, let's talk about the core rules of tic-tac-toe. The game is played on a 3x3 grid with two players represented by X and O. Players will take turns placing their symbol in an empty cell on the grid. The goal is to be the first to get three of your symbols in a row, either horizontally, vertically, or diagonally. And if all cells are filled and neither player has achieved a winning combination, the game ends in a draw. These rules form the foundation of the game, and AI will need to follow them precisely to create an authentic player experience. Now let's talk about what constraints we'll place on AI itself. AI can only make valid moves. For example, it can't place a symbol in a cell that's already occupied, and the AI's goal is to win, but it must play fairly. It won't be allowed to skip turns, alter the board state, or make impossible moves. And by enforcing these constraints, we ensure that AI behaves like a legitimate player rather than exploiting the system to win. Next, we'll have constraints on the flow of the game. The game follows a best of 3 format, so the first to win 2 rounds is declared the overall winner. To keep things fair, the AI and user will alternate who starts each round. This avoids giving one side a constant advantage. These constraints help balance the game, making it more engaging and competitive. Managing time and interaction is another key aspect, so we may decide to implement a time limit for the user's turn to keep the game flowing smoothly. And user input will need to follow a clear format, such as entering coordinates like 1, 2, 3, all the way to 9 to place their symbol. And AI should also respond within a reasonable time frame to avoid frustrating delays for the user. And setting these boundaries ensures a responsive and enjoyable experience for the player. Since we're using Diffie AI, there are some technical limitations we need to consider, such as Diffie AI does have limits on token usage and interaction length, so we need to design our prompts carefully to avoid running into these restrictions. We'll also need to decide how the AI perceives the board. For example, we might use a string representation or a matrix to understand the game state and make decisions. Handling these technical factors properly will help our system run smoothly and make intelligent and context-aware decisions. And finally, let's talk about how we'll handle scorekeeping and the game outcomes. The system will track wins, losses, and draws throughout the best of the 3 series, and after each round, the current score will be displayed to keep the players informed. And we'll also account for edge cases, like what happens if there are 3 consecutive draws. In that case, we might consider declaring an overall tie or just adding an extra round to break the tie. And by carefully handling the scorekeeping and edge cases, we make sure that the game feels complete and well structured. Thank you.
Now, we're going to be talking about our approaches, which are our strategies and techniques for how we're going to build an AI to successfully be able to beat a person in a game of tic-tac-toe. Our first strategy would be through reinforcement learning. This is where the AI learns from experience, the repetitive playing, and trial and error. It uses the game point system as feedback for how it's performing. For example, when the AI successfully wins a game and is rewarded with 1 point, it will take that as positive feedback and will remember the strategy that it last used. However, if it loses a game and receives a negative point, it will take that as negative feedback and continue to adjust its strategies for the next game that it plays. One of the pros of this strategy is that it does not require any pre-programming, but that can also lead to a con of taking too much time to train the program. If the program is not trained correctly or not trained enough, that could possibly hinder its performance when playing games. Otherwise, we can go with the pre-programmed strategy, where the AI will already be hard-coded with a simple set of rules and enforced with conditional checks such as prioritizing its winning paths and blocking the opponent's winning paths. But if they currently do not have one, then the AI will continue with its own current winning path or any other free spot that is available on the board. This strategy is quick and does not need any further training for the AI to learn how to play the game. However, it is very simple and it may not win against players who are more experienced and use more complicated strategies. Lastly, we could also use the predictive strategy. While it is similar to the pre-programmed strategy, there are still a few differences. The predictive strategy allows the AI to use the probabilities of different outcomes to decide on its next move. It runs simulations of how the game is going to go with future paths and makes decisions based on the future of the game and not just its current state. It can adapt more than an AI that uses the pre-programmed strategy and handles more complex scenarios based on the opponent's behavior. However, using this strategy would be resource heavy because it will be constantly running multiple simulations at once throughout the entire game. Additionally, since tic-tac-toe is a very simple game, there are only so many simulations to run, which could result in the AI making the same patterns repeatedly, allowing the person to predict what the AI is going to do next and counter it. However, we are also bound to run into some difficulties. For example, the AI machine could be underfit, which means it is not trained enough and it fails to recognize some winning paths. If this happens, we would need more time to train the AI, or find ways to effectively train the machine to learn more in a shorter amount of time. Similar to being underfit, we can run into another issue where the AI has a lack of adaptability, which means that it struggles to perform well against simulations that it has never encountered. It would only perform well against data that it has already seen during training. If this happens, we would include the reinforcement learning strategy so that it could learn from experience and continue training it with different data.
Hello everyone, my name is Ratul and I'll be discussing how we can test the AI in our tic-tac-toe project to ensure that it follows the rules, it plays fairly, and provides a good user experience. So let's start by looking at two key testing methods, automated testing and manual testing. So first we have automated testing. This involves scripted simulations where AI plays against a simulated opponent. The opponent can be programmed to follow a specific strategy, such as random moves, optimal play, or even a strategy designed to expose weaknesses in the AI's decision-making process. After running these simulations, we can compare the AI's moves against expected legal moves. So this helps to determine if it's making valid choices based on the game rules. So additionally, automated testing allows us to quickly identify major issues. For example, we can detect if the AI is making illegal moves, like overriding an existing symbol, skipping its turn, or even taking multiple moves in a single turn. By automating this process, we can efficiently validate whether the AI consistently adheres to the rules across many test runs. Next, we have manual testing, which involves real human players playing against the AI and providing feedback. This step is essential because it helps us evaluate more than just the AI following rules. It also lets us gauge the fairness, the difficulty, and overall playing experience. So one key aspect of manual testing is checking if the AI properly alternates between who starts each round. Since we're using a best of 3 format, the AI should correctly take turns starting each game to keep things balanced. So we also need to verify that the game state resets correctly between rounds. So this ensures that the board clears properly and the AI does not retain information from previous rounds that could impact its decision making unfairly. Okay, so in this slide we have two pictures right here. So this is automation testing, and usually automation testing, the parts that the testing that is part of it is load testing, performance testing, database testing, security testing, and stress testing. Not all of these are relevant in our use case scenario, but these are the components of automation testing. So for the components of manual testing, we have acceptance testing, black box testing, white box testing, unit testing, system testing, and integration testing. Once again, not all of these will be relevant for us, but just to let you guys know, these are the components of each testing, such as automation testing and manual testing. So now that we've covered these testing methods, let's move on to a more in-depth testing techniques, including stress testing, edge case analysis, and logging and refinement. So here we have testing on edge cases as well as logging and refinement. So let's start with stress testing. Stress testing is crucial for evaluating how well the AI performs under different playing styles and over multiple games. We want to see if the AI remains consistent and behaves correctly no matter how the opponent plays. For instance, we can run the AI against different opponent types. So players that make random moves, optimal players who always make the best choices, or even the worst case scenario opponents who deliberately set traps for the AI. By doing this, we can expose any weaknesses in the AI's logic and refine it accordingly. Additionally, playing multiple consecutive games helps us check for inconsistencies. Does the AI start behaving strangely after multiple rounds? Does it forget the game rules by that point? By stress testing, we can make sure it maintains correct behavior over time. So then we can move on to edge case analysis. So um, edge case analysis focuses on identifying and addressing rare or unexpected situations. For example, one of the most basic but critical tests is making sure the AI never places a symbol in an occupied cell. If it does, that's a major violation of the game rules. Another essential test is whether the AI recognizes a winning move. If there's an opportunity to win, the AI should take it immediately. Similarly, it should also recognize when the opponent is about to win and block them whenever possible. This ensures the AI plays competitively and doesn't make avoidable mistakes. We also need to assess the AI's strategy. Does it prioritize strong moves, such as taking the center square or corners first? Or is it making random suboptimal choices that, a normal person wouldn't make? Lastly, we need to check how the AI handles unexpected inputs, like a user attempting to enter an invalid move, or if duplicate moves are mistakenly processed. This helps ensure that the AI remains robust and doesn't break under unusual conditions. Finally, we can talk about logging and refinement. So logging and refinement is a key aspect in improving the AI's performance over time. By keeping a log of the AI's responses and game states, we can analyze patterns and identify inconsistencies. For example, if we notice that the AI occasionally makes an illegal move or fails to block a win, we can pinpoint the cause by reviewing the log data. This allows us to adjust the AI's prompt wording to reinforce specific rules or constraints, because the AI might be struggling with certain scenarios or certain rules. So we want to be able to log that and then address that later. For instance, if the AI struggles to recognize winning moves, we might refine the prompt to explicitly state before making a move, check if there is a winning move available. If so, take it immediately. So small changes like this can lead to significant improvements in AI behavior. So in summary, testing our tic-tac-toe AI requires a combination of automated and manual testing, stress testing to ensure consistency, edge case analysis to catch rare issues, and logging to refine AI behavior over time. By applying these strategies, we can create an AI that plays fairly, follows the rules, and provides a great gaming experience. Now, I'll be handing off the next slides to my groupmate.
Hello, my name is Jason. Um, I'm gonna present the tech stack and our goals for the end of the semester. So while we're using our AI, which is tic tac toe AI, our baseline, which is at the bottom, will be using Python, since most of the industry uses Python for its code for making AI. There's also JavaScript and R that they use, but we'll stick with Python since that's what we mostly know. We're going to be using the assistance of Diffie AI. It will help us to create and understand more of the technical stuff of making this, of not of making this, of understanding this AI, this tic tac toe AI. We're also going to be using training data of many different tic tac toe games, and then after that, we're gonna split it in half, or 90% training, 10% we're gonna use the testing data. The reason why we are gonna use this specific outline is because we're just barely learning AI, so that's why we need to use AI itself in order to help with the understanding and further exploring our tic tac toe AI. The reason why we're using Python is because, as I said, it's the one of the main programming languages used by the industry from many different companies, and also because as a group more we understand Python and Java Python more than like JavaScript or R. Personally, I don't know what R is. Also, of course, we need training data and testing data in order to fine tune our AI, like how our weekly videos shown that fine tuning is the biggest part of this whole process. So, what are our goals for the end of the year, end of the semester? High level understanding of the RNets, being able to comprehend many different aspects revolving neural nets, such as their hidden layers and the input and output layers, will help us further give ourselves an understanding of how to use AI for ourselves, and also to further educate us when we go into the job market, since AIs are going to be a big part of the job market as of right now, and especially when it's further and further getting more advanced, as we say. As it goes on, broad understanding of LLMs is very important because using LLMs such as ChatGPT and Notebook LM, Diffie AI, is very important because with the rise of AI, everyone's going to start using it. And the better understanding you know how the mechanisms work behind the scene, the easier it is for us to use them ourselves and get the appropriate answers with the least amount of errors going through it. Different types of AI is used throughout the industry. This is, again, important because if many people are using AI, you'll be at such a disadvantage if you don't know the different types and how to use each type, and understanding when you want to use one company's AI versus another company's AI. So understanding this now will greatly improve our chances in the future with any goals that we may achieve. And the last thing is just using AI to the best of our ability, for it being for recreational fun or for business. Just understanding how to use AI, especially right now, and understanding how it looks at the end will give us a good understanding of when maybe AI is using it for the right reasons or the wrong reasons, especially now with deepfakes and AI generated images and videos that might, if being looked at by the untrained eye, will be will be misleading and will fall you down to like many different bad endings, such as falling for propaganda. Thank you. Come again.